Hello and welcome to another lecture on data structures. Today we are going to discuss graph traversal, which refers to the process of visiting each vertex in a graph. There are two types of graph traversal: depth first search and breadth first search. We will start with depth first search. In this approach, we use a stack to remember and track the vertices we plan to visit. All adjacent vertices are pushed onto the stack. If there are no more vertices to visit from the top, vertices are popped from the stack. Let's get started with an example. Suppose we're given a graph. The first step is to pick a starting node. This is completely up to you. You can choose any node you like. I prefer to start with node B. We add node B to the visited list. Then push all its adjacent vertices onto the stack. Its adjacent nodes are A and D. Again, it doesn't matter which one you add first, so I prefer to push D and then A onto the stack. As observed, these two nodes are the only adjacent nodes of node B. Now we must visit the top of the stack. Note that we always add or remove an item from the top of the stack. Following this rule, node A will be visited next. Mark A as visited and add it to the visited list. Now add all of A's adjacent nodes to the stack. Node C is the only adjacent node to A, so we push it onto the stack. Node C has no adjacent nodes, so mark it as visited and add it to the visited list. At this point, there are no unvisited adjacent nodes of C. To continue traversal, we pop items from the stack to check for remaining unvisited adjacent nodes. Pop C and A from the stack as they have already been visited, and now we reach node D. Mark D as visited and push its adjacent node, which is E, onto the stack. Node E is adjacent to D, so mark it as visited and then add its adjacent node, which is F, to the stack. F has no adjacent nodes, so we mark F as visited. At this point, there are no more unvisited adjacent nodes. We remove any remaining items from the stack to check, but now all the nodes are visited and the stack is empty. Now let's move on to breadth first search. The process is a little different because we use a queue instead of the stack used in the depth first search. Again, choose any node you like. It's completely up to you. I choose node B and add it to the visited list. Now add all its adjacent nodes to the queue. B's adjacent nodes are A and D. The order doesn't matter, so I insert A first and then D. Please note that when processing nodes in a queue, we start with the node at the front of the queue. So the next node to process is A. Mark A as visited and add its adjacent node C to the queue. Then add A to the visited list. Next, process the node D and add its adjacent node, which is E, to the queue. D is added to the visited list. Now process C. C has no adjacent nodes, so simply add it to the visited list. Then process E. E's adjacent node is F, which we add to the queue. Mark E as visited. And finally, F is processed and added to the visited list. At this point, the queue is empty and the traversal is complete. I hope this video was helpful and thank you for watching.